So continuing from the last session 3.2, it is 3.3. So you can say that we can, if you have two or more than two categorical variables in your data set, then it is better to use chi-square test. Chi-square test is a statistical test, and why it is used? Because it is non-parametric, one of the non-parametric. It is parametric. Parametric means it is created, it is developed using normal distribution, but still chi-square is also a part of non-parametric analysis. Non-parametric analysis is the field in analysis, data analysis and statistics, which assumes that your data is not following any distribution. That means you don't need normal distribution assumption if you are using normal distribution. So it is very blessing that it's a very big blessing that we have chi-square distribution, t-distribution. And the concepts from statistics are copied into data science, data mining, and machine learning as well. So if you have good understanding with these fundamentals, you will enjoy more. If you don't have, you can learn online very easily. They are not very difficult. So yeah, the correlation of hospitals, number of car left in a city. So how many hospitals, how many car left, they are correlated. So for example, in Karachi, you see there are large number of bikes, motorbikes. Large number of motorbikes have a relationship with the number of accidents. One person was doing research on it. So in Karachi only. And if it is a slippery road because of rain or any grease, there is a relation of slippery road with number of accidents. Number of accidents is assuming it's a countable discrete value or categorical variable. So we can use chi-square test in situations where we have categorical variables. We will see this again in clustering, yeah, and as well in other topics. And yeah, this is an example, simple example. Do you like science fiction movie and not like science fiction or movie or books? And do you play chess or you don't play chess? So 250, this 250 is the actual observed values. For example, you have 1500 people that you surveyed. Out of 1500 people, 250 people said they like science fiction, and they also play chess. And 1000 said they don't like fiction, they don't like chess, they don't play chess. And 200 this category like fiction, science fiction, but not play chess, and 50 who don't like science fiction but play chess. These bracket values, these are called expected frequencies or expected counts. This count is calculated based on this 450. So if 250 plus 200 is 450, there is a formula that we take the sum of, we take the column value 300, column sum 300, row sum 450. So 300 times 45 times 3 is 135. So it is 13,050, 135,000, 1350, 13500 divided by 1500. So 13500 divided by 1500 is approximately 90. Similarly, how we get 360? We say the corresponding row total is 450 times 1200. So 12 times 45, I don't. So 45 times 12 and 000. So you can get, and divided by 1500 total, you get this way. Here you see, after calculating this bracket observations, then we have chi-square, which says 250 minus 90 squared, 250 minus 90. For each cell, we calculate this. 250 minus 90 squared divided by 90. So this is a formula that you, if somebody have done BSc or BCom, they have studied in BCom or
otherwise. We did this in second semester modeling and inference course. We did this.
Modeling and simulation, this thing.
Modeling and inference course in MCS. We did it, I think, in second semester.
Okay. Okay. Who taught that module? Who taught that course?
Ms. Shaista Rais. Ms. Shaista Rais.
सारे स्टूडेंट शाइस्ता, मत्ता, हुमैरा, मेरा बशीर, सब स्टूडेंट हैं, सबको एमएस में पढ़ाया है। मेरा बशीर past. Anyway, yeah, time is passing very fast. So we can say, is there any relationship that if somebody likes science fiction, he also like to play or not to play chess? What we did this calculations, 507.93, and from this value, I did not did anything. If this is the chi-square value, we can find the p value corresponding to this value, which is called how significant, how strongly significant association we have between like and dislike of science fiction, and either the person play chess or not play chess. So if the p value is less than 0.05, that means there is strong association between these two categorical variables. If the p value is less than 0.01, even stronger, that means we say yes, there is even more stronger association between them. So when it is the association is 0.0, p value is 0.05 or less than 0.05, what we have to do, we either have to remove play chess or not play chess variable from your database, or you have to remove the like or dislike, like or not like science fiction variable from your data. So this is one of the simple approaches where you can use chi-square test and remove the variables which are strongly correlated with other variables. I gave you two examples. This example is for categorical data, and the other example in R that we did was about, the other example was about numeric data, and the numeric data was from Iris. So this is numeric. So even in the core, you can define which method you want to use. For example, if you have categorical and numeric data mixed together, for example, gender and distance from home and average salary, average work hours, and number of employees in the office. So if you have some data which have both categorical, character, and numeric variables, then you can define which way of correlation you want to use. I think maybe you also have studied there are multiple, there are different ways of calculating correlation. One of the approach for calculating correlation is Spearman's correlation. It is a way which is non-parametric. Non-parametric means you don't assume any assumptions, statistical assumptions about the function, about the variables. But if you use the Pearson, normally we use Pearson correlation. If you use Pearson correlation, we assume that we have some assumptions about the data. So that's why you have to look inside your data, whether your data is happy, or your data should have a Spearman correlation, or you should have a Spearman correlation, or there is tau B, tau C, and maybe some other formulas for calculating correlation. So correlation analysis is part of data analysis and data science. I think library. I don't need library because we have seen correlation maps last the last session. So this analysis is for categorical data, which is chi-square, and when it is numeric data, we go for correlation. This is simplest. Okay, next is yeah, we have covered this, and this is a visualization. If I go to here, correlation visualization R, you will see a very great matches. It's a very there are many different ways like this. We did not cover this way, where you have dots representing the strong correlations or weak correlations, and we have numbers here as well. So see, some package is doing like this as well. Some package is doing correlation matrix only, because correlation matrix is symmetric matrix. So either you can represent it by upper diagonal or lower diagonal. You don't need to represent both upper and lower because it will take memory. You can have this visualization. You can have heat map type visualization. You can have this thing. I have not used this type of correlation testing. And you can have psychology package, which have this type of analysis and correlation analysis. So see, there is not a single package. There are so many different ways of doing correlation analysis and checking for good and bad correlation. See, so it's I don't close you, I don't restrict you. It's up to you which package you like the best and which visualization you want to use. So the better you do, the better grade it. बाकी ये क्योंकि फाइनल ईयर है, अभी तक आप लोगों ने टेक्निकल राइटिंग सीखी और इस वजह से भी प्रोजेक्ट फॉर्मेशन करी है। ये मैंने आपको बता दिया था 2 से ज़्यादा जो लोग होते हैं उसमें कुछ लोग नॉन ह्यूमन शामिल हो जाते हैं। तो ऐसे 4 का ग्रुप बनाए, ये लॉजिकल है। Anyway, if I go back, transformation. I jumped directly because this is 19th slide I have reached and there is a lot of to do. I just go to the topic that I want to cover is normalization. Normalization means we want to convert our data having the similar measurement units for all the variables, similar range of values. There are many different ways. For example, this is saying if you have a column vector, suppose V, you subtract the minimum value, you take the range of the values, and this is calculated. But this one is a new one, which is new maximum minus new minimum. You can change, you can say it is salary column. Suppose the salary is from 0 rupees to 100,000 rupees, but I want the salary from -1 to +1, or say 0 to 1. So I will use new maximum is equal to 1, new minimum is equal to 0, and plus new minimum is equal to 0. And my actual minimum was 0 and maximum was 100,000. So that's way you can calculate the transformed or normalized variable using your new observation, new expected observations, new transform values, and the actual value. Here in examples. Example that income from 12,000 less than from 0 to 1, then 73 is that mapped to 73 take away minimum divided by maximum minus minimum. New range is 1 to 1 minus 0 plus 0 is 0.76. So that means 73,000 became 0.716. So this is a good transformation where all of your for all the salaries it will become different one. And if you have different number of columns, that's not like 10-20 columns, you can write a function and you can convert all of them using that function. The second very common approach is Z-scores, but this approach is more suitable when your data is normally distributed. If the data is not normally distributed, it is not recommended, but still people use it and they get the results. But many times the result is misleading. Don't use normal Z-scores formula unless your data is normally distributed, or you can convert the data into normal distribution. If your data is normally distributed, then go for Z-score normalization. For example, that the mean salary is 54,000, variation, standard deviation in the salary is 16,000. Then yours, suppose the salary of 76,600, take away mean divided by standard deviation will be 1.5. And understand that any value, any Z-score value which is more than 3, more than +4, or less than -4, that will be assumed as outlier observation. Outliers are those observations which are very different from the rest of the data set. Jesse, for example, if I say the average salary is 100,000 in Pakistan, average salary is 100,000 in IT sector, and suppose some person have a salary of 1 million per month. That means this is different from the rest of the data set, and that will be a mild outlier or maybe a potential outlier. So these are simple common sense. Some data you can just divide by 10 or 100 or 1,000 or 10,000 or 100,000, and then you will get scaled observation. For example, salaries 73,000 divided by 10,000, it will give me 0.73. So you can convert your data between 0 and 1 using this transformation as well. But this is not the end of word. This is academic course. That's why you are looking only those which are usually used in books and academic. If you go to professional, then normalization techniques in R, then you can see more and more normalization data normalization norm ALR. You will find this is just an example. Norm 2018 normalization of multiple variable in large scale database. So if you have a large data set, because large data sets might have different behaviors than usual small data sets, then you can use a different package. It's not very big package, and you can try this one. You have, so you can search, because the package I used, it was very nice, and you have to search that so that you
सर
can.
इसकी कोई प्रॉपर बुक बता सकते हैं कि मतलब इसको फॉलो करके आर के ऊपर ये सारे काम करवा के हम उसको यानी कोई बुक हो इसकी, कोई गाइड या कोई आप रेकमेंड करना चाहें?
इस तरह से पढ़ा रहा हूँ, उसके लिए तो कोई बुक नहीं है। बुक पढ़ेंगे तो आपको तकरीबन 300-400 पेजेस की बुक पढ़ना पड़ेगी। तो
मसला नहीं है सर, लेकिन बता दें अगर है तो।
गूगल पे देखें, गूगल सर्च करके देखें, जैसे मेरे
अच्छा,
सामने
मतलब
दर्जन के,
मैं
बल्कि
समझ,
आप गूगल ना करें, बल्कि आप जो आर के डॉक्यूमेंटेशन है वहीं चले जाएं। ये आपको शायद आया था, नहीं बताया, ट्यूटोरियल्स, देन यू कैन सी लर्न आर पैकेज, और लर्न आर पैकेज चले जाएं तो वो आपको, I mean R itself has a lot videos, questions, exercises, tutorials, so you can have a lot of stuff with practice. और वो ये है कि आप टाइम जितना स्पेंड करेंगे उतना आप लर्न करेंगे। मिनिमम रिक्वायरमेंट ये है कि जो कोर्स में पढ़ाया जा रहा है वो आप कवर कर दें। कहाँ तक जाना चाहते हैं वो आपकी चॉइस है। बहुत कुछ है, आई मीन अब तो वहाँ तो फर्स्ट ईयर में आर पढ़ाया जा रहा था, और यहाँ पे हम फाइनल ईयर में पढ़ा रहे हैं। वहाँ पे BS फर्स्ट ईयर में पढ़ा रहे थे, तो काफ़ी ज़्यादा वहाँ पे एडवांसमेंट हमें जो है उस ज़रूरत है। यहाँ पे लोग नहीं मिलते मार्केट के अंदर, तो उस वजह से ये सारी चीज़ें आप जितना लर्न करेंगे उतना आपको जो है वो बेनिफिट देगा। है, मैं जो है वो एक्सपीरियंस चलता हुआ आ रहा हूँ, तो इसलिए एक्सपीरियंस बेस्ड है, कुछ लर्न बेस्ड है। Yeah, so you can use this, you can have more packages. स्लाइड्स मेरी बिल्कुल नहीं है, मैंने पहले बताया, टाइम नहीं जैसा रीजंस की वजह से, ये मैं आपको क्लियर करता हूँ। This is one way. Discretization, you can convert numeric data into categorical data. This is called binning process. I don't know if I not write code for that. Binning means, for example, salary. You can say low salary, high salary, very high salary, or very low salary. You can discretize a salary column. A salary is a numeric column into category. Similarly, age column, young and middle age, old age, or very old age, something like this. So you can categorize a numeric data into categories. Even yeah, आप कहते हैं ना diastolic, yeah, blood pressure, normal blood pressure, not normal blood pressure. So this discretize diabetes, glucose level, I mean, so everywhere where you convert your numeric data into categories, that is called discretization. Discretization is good that it makes the observation simplified. For example, if I say a patient has 85 and 115 blood pressure in the range of 85 to 115, you call it normal. So saying normal means understood it is between 80 and 120. I don't need to say specifically it is 85 or it is 115. So discretization is useful because you can understand the data more easily. But discretization also causes loss of observation. If I say the blood pressure is normal, normal can be like 80 and 120, or normal can be between 90 and 115. So this is that when we do binning, when we do discretization, we use actual behavior of the data. Plus, we cannot go for normal distribution. We have to go for categorical data analysis, which is non-categorical or non-numeric data. I mean, which is counting values, for example, grading, for example, diabetes. So, so there is a lot of many different techniques. Some of them algorithms are available. We will cover next. Discretization. Discretization. Yeah, there is a complete package. Click it and you have a package. In R. R is very much strong in 2015. Most of the packages you will find within the last 5 years or 2 years. So discretization by chi-square, I don't know many of them, I have not used all of them. So you can explore. This is exploratory. Data mining is exploratory analysis. The more you do, more you get. Conditional autocorrelation. Oh, I don't know what is the name. Yeah, class attribute contingency coefficient. This is another. I have not used it in my research projects. So, but you can, if you are doing a joint project with your team and you are using some package, you can refer to that package. You can write this formula and say, yes, we have used it, and reference. You have to give the proper reference if you are using some package. ऐसा सब्जेक्ट है कि जितना सीखेंगे आपको बेनिफिट देगा. Fun modeling. So you see, there is a lot of stuff. Even we don't know exactly, when as a data scientist, we don't exactly know which package is the best for our analysis. Sometimes we have to see multiple things, and based on that, we say, yes, this is the best. Fun modeling and deployer. So you see a lot of many websites where you can learn and understand the concept. But because limitation, time limitation, and contents limitation, we cannot cover everything in this single. Data discretization can be understood by binning, by histogram, histogram. Cluster analysis, we will see cluster analysis where we can split the data into different chunks, and each each subset of the data set will have similar behavior. Then you can do a discretization there. Decision tree, we will see decision tree in 7th or 8th week, and we will do it. We have done this chi-square. Chi-square is a non-parametric, and they calling it supervised as well. But we have done correlation. So correlation we covered. So we come back to correlation and integration. Yeah, you can read through equal bins if you have some data which is not skewed. Skewed data means you see most of the people has in Pakistan has an average salary, if I'm not wrong, 25,000, the whole country. But there are people having salary more than 7 figures, 6, 7, yeah, in 7 figures or 8 figures. So then we call it skewed observations or skewed data set. Then we cannot assume equal width and equal depth. Then we have to change histogram with having unequal intervals or unequal bars. Yeah, you can read through this example, and this is the discretization where your data is converted into chunks, splits, 1 split, 2 splits, again, like people having good experience or having bad experience in professional experience. So, but I not that. Yeah. So yes, that's it. So your job today is to read through these slides, because this is a very big lecture by Han, and I'm sure it is like minimum 3 hours to 5 hours lesson, roughly 5 hours, because the concept of PCA and other concept, they will take time. I have a separate session for PCA, separate session for FA and clustering, but in this chapter they covered everything in 63 slides, which is not really possible in this time. So your job is to practice these things, read through these things because they are quite verbal. Read through these slides, and if you have any question, ask here. We have a chat group, WhatsApp group. You can ask there, and then if you start working towards project, still there are missings. मुझे कोई बताएगा? एक मिनट इसको stop.